In this lesson, we will look at the GoalSeek capabilities available both in CAD Calcs and GraphicCalc 2010. GoalSeek really essentially a way of back solving geometry to meet and satisfy a stipulated design goal, and the goal can be a value which has been measured or calculated. So you can goal seek any geometry which affects that measured or calculated value automatically to satisfy design challenges that benefit from optimization against stated shape, position, and fit design criteria. The GoalSeek capability works on the lengths of lines, the angle of lines, and radius of circles. These are the three things that you can goal seek. You can goal seek the angle of any line, the length of the line, and the radius of a circle. Now, when coming to the length of the line, you have to be a little careful. If the line is going to expand in both directions, you have to follow a certain method. If it's going to expand only in one direction, you have to follow another method. So I'm going to show you how do you goal seek the length of a line, both the situations. And there's a pretty straightforward example I can set up. Let's say I have a line here, and I'm going to constrain the line from its midpoint going up. And I'm going to take the arc, 3-point arc tool, and constrain it from the endpoints of these three lines. So now if I calculate the length of this arc, I just click on the arc, and this is the length of the arcs. So, and let's say I have a target for the length, so I can stipulate the target. Let's say we want the length to be 55 millimeters. So I have two options. Either I can expand this line, the baseline, and that'll change the length of the arc, or I can expand the length of this line in this direction. That will also get me the result. So let's look at the two scenarios. Let's change the length of this line so it is expanding in one direction. This is most often the case. So you select on the entity, click on the entity to select it, and then I double click on this point to activate my length constraint, and then I say goal seek. So first I have to click on the actual value, which may be a calculated value or a measured value. So in this case, this is a calculated value. I want to make it equal to 55 millimeters by changing the length. So I click on the letter L in the value bar. You click on the freedom that you're goal seeking. And I have an answer. Let me undo this. The other way around, if I am going to expand the line on both sides, I don't have to activate the length drop point. I just click on the line, and then I say goal seek. You can also enter the value directly in the goal seek dialog, 55 millimeter. Bring the cursor here by varying the length. Now the line will expand in both directions. You can see that. So this is how you back solve the length of a line. Let's take an example of goal seeking the angle of a line to satisfy a design challenge. I'm going to set up an arbitrary shape here, and I've got a hole in it. So I declare this to be an area. And let's calculate the moment of inertia of this shape. So I take a cell, place it somewhere here to locate it, click on the shape, and substitute the built-in function. So that's my moment of inertia. Let me make it little, take some of the precision away for display purposes. Right mouse button, set decimals 0. So the displays, the zeros are stripped. Now let me set up a target for this. Let's say 1, 5, 0.0000 millimeter to the power of 4. One thing you have to keep in mind, the target values units have to be the same as the source values of units. So you cannot mix units. And so I want to make the moment of inertia of this shape equal to my target value by changing the length of this line. So click on the line, say goal seek. This is the actual moment of inertia. This is my target moment of inertia by changing the angle. One thing you have to keep in mind that your target value should be reasonably close to the actual value, and there must be a solution that the geometry can deliver, otherwise it'll go into a cycle. And now if I change an input condition, for example, I change the size of this hole, you will see that the goal seek will kick in automatically. This is very powerful. It can save you a lot of time. Let's see an example of this technology when we are back solving the radius of a shape. So I'm going to bring in a real life example. User is doing a deflection calculation of a beam, and it's a non-standard section, so the actual deflection calculation here is using the built-in function to calculate the moment of inertia, and the target deflection is 0.0250 millimeter. My variable is the size of this hole, so I want to goal seek the radius of this circle. So I click on the circle and then click on the radius constraint and say goal seek actual value to target value by changing the radius. And once again, if I change the input condition, for example, if I made 1000 kilograms here as a load, so now the shape has to be different to accommodate that. So you